Hello there, 2D folks. Another Restall's not here video thing. So, supervising teacher, if you could just pause the video here, let the kids copy the 3-minute review question into their notes, the first of the week. We'll take it up once they've had about 3 minutes to try it on their own. So pause the video now, please. Okay, here we go. The idea here, typical word problem, and we want to set it up and get a couple of equations to answer the question. Now, as we'll see today, a theme for us is trying to figure out what to let the variables be. And usually a good idea is to let the variable be whatever you're asked to find. So in this case, how much does each item cost? So I let E be the cost of an egg, B the cost of a slice of bacon, and then I use the two sentences, well, it's two thoughts anyway, one sentence, two thoughts, to come up with the two equations. And it reads perfectly. 2 eggs and 4 slices of bacon is $6.60. 2 eggs, 4 slices of bacon cost $6.60. There's the first equation. Similarly, there's the second equation. Excuse me. And because none of the coefficients were ones, I chose to use elimination. I chose to eliminate the e's this time. I multiplied the first equation by -3 and the second one by 2, added, and it was all good. I got negative b equals -1.70, and then I got a slice of bacon cost 85 cents, substituted back into 1, and I got the answer. Okay? Notice my steps, and I'll let you look at that in a second. The steps A, B, C, D were from the problem-solving recipe that we came up with early last week, a couple classes ago, last class actually, and the last one was to make a statement and check our work, and that looks good. So today we've got actually a couple of sets of word problems, and I'm going to go pretty quickly through this video. So you know, if I'm going too fast, pause the video. Remember, 2D'ers, the link to this video will be on the website, so you can look at it again and again if you like. But here we go. Word problems 2. Solve problems involving 2 linear equations, including those that arise from real-life situations. And this is the theme for this week. This example, the length of a rectangle is 6 inches more than triple the width. The perimeter is 3 feet. That means feet, that's inches. Find the dimensions. Well, if I just follow my problem-solving, word problem-solving, I'm going to let the variables represent the things that I want to find. So here, L, let L be the length, right? I think the length and the width are all I want to find. And then step B would be to write the equations. Well, each sentence has an equation. The length of a rectangle is usually means equals. The length is 6 inches more than triple the width. So what's an expression for triple the width? That's 3W. And 6 more than that would be plus 6. The perimeter is 3 feet. Well, notice that this is in inches, so I want this to be in inches. 3 feet equals 3 times 12 feet, or 12 inches in a foot, 36 inches. So the perimeter is 36 inches. Well, remember, what's the little formula for perimeter of a rectangle? Well, it's 2 L's and 2 W's. We could have written it like this if we wanted to. But this expression, the perimeter, is equal to 36. So there's my second statement. 2 L's plus 2 W's is equal to 36. And there's my 2 equations. And this one looks like a substitution question. So I'm going to sub 1 into 2. Notice what I did when I when I'm substituting into the second equation, this is kind of my practice, is I'll leave a hole where the L is, then fill it with the expression that L is equal to. And then grade 9 equation stuff now, right? And we're getting pretty good at this. And in fact, later today, soon, we're going to be solving questions, setting up word problems, but not solving them, because if we solved every single problem that we were asked to do today, it would take us about 3 classes worth to do all the examples. So we're going to sort of cheat a little bit once we get to it. I subtract 12 from both sides, and I get the width is, divide by 8, the width is 3, sub back into and I get the length is 3 times 3 plus 6, that's 9, 15. Therefore, the length is 15 inches, and the pen's conking out here. Width is 3. Now, if it was a normal class, if I were there, we would spend some time doing that homework stuff. But I'm going to continue with the rest of the lesson. The rest of the examples should be on a handout that you've probably received. And these ones, I'm actually just going to go through the setup. And I'll explain how this is going to work here. So we've got 4 examples. Each of them are a different type of sort of word problem. And these are actually getting pretty difficult because there's a lot of information here. So instead of the A, B, C, D technique of setting up these, I'm going to go to the grass technique. So what's given in this question? Well, there's a whole bunch of stuff. 1,250 people attended. And you're doing all this work on a separate piece of paper, right? You can't squish it on that piece of paper that I gave you, or the supply teacher gave you. They raised $13,300. Raised. What other information is given? Well, full price tickets. Full price were $12 each, right? And discount were $8 each. What are we asked to find? And this always, what are we required to find? That's the second letter in grass. How many of each type were sold? So that'll tell us what to set up. So how much of each type were sold? Well, maybe I'll let F be the full price tickets. Tickets sold. And what? D for discount. D are discount tickets sold. And somehow I'd like to organize all this information into, in the analysis stage, we get our 2 equations. To come up with the 2 equations and 2 unknowns. Now, how am I going to do this? Well, there's a couple of things going on: the value of the tickets and the number of the tickets. And I like setting this up in a chart, and I'll show you what I mean. So what do I got? I got a few things going on here. I've got the full price tickets and the discount, and I also have the total, right? Because at 1,250 people that showed up were both types of tickets combined. So I have the number of tickets and the cost or the value of the tickets. I like calling these value problems. This is a value problem. So the number of full price tickets, well, that was our F, wasn't it? Our discount was D. Number of discount tickets was just D. and I know that we had to have 1,250 people in total. I can see an equation coming from this, can't I? The value, well, each ticket, full price ticket, was worth $12, so the value of the full price tickets was 12F. The value of the discount tickets was 8D, and in total, we raised $13,300, and I can see a second equation. So here's our two equations. That's going to come from the analysis step, folks. F plus D is equal to 1250, and notice that that one's pretty close to ready for substitution. Certainly it's ready for elimination. I'm going to call that equation 1. And 12F plus 8D is equal to 1330. And that's equation 2. I'm not going to finish solving these because we want to get through these examples sometime today. The answer ends up, and I'm not even going to write it, but what I have done, folks, and you can print this off or you can check it later, this will be on the Facebook group, and there's the entire solution there, okay? We see the final answer is there were 425 discount tickets and 825 full price tickets, but I must have made an error there, 825. Good. Example 2, mixtures. So again, we've got peas and carrots are mixed together for 20 kilogram mixture sold for $1.15 per kilogram. How much of each should she, the green giant, mix? Okay, well, what I'm going to do is put in the given and the required all in one step here. Set this up in a chart. What do we got? We got peas and carrots. And total, right? The total. How much of each should she mix? Well, that's the amount, or the kilograms, right? And I'm going to call that P, and this C, and I know that we want to have 20 kilograms in total. Then again, we have this value line, right? Well, what's the value of the peas? That's $1.75 times P. The value of the carrots is, notice that it was in cents, but I got to change that to dollars so the units match up. Now, what's the total value? Well, each kilogram is worth $1.15, but there's 20 kilograms, so the total value is 23 kilos. And out of this, I should be able to get my two equations. Notice the amount has to add up to 20, and the value, pen problems here, has to add up to 23. And again, if you want to multiply by 100 to get rid of the fractions, you can do that. If you're willing to do with the decimals rather, if you're willing to deal with them, you can. I think what I did, and I'm going to stop there. That once it's set up, this is just a routine old system of equations to solve. And again, in the note, I do have my full solution that you can print off or check and see. Notice what I did is I changed equation 1 into substitution, then I substituted, and it was all good. Actually, this one didn't work out perfectly. It was a decimal, but that's okay to have decimals of kilograms of peas and carrots. And that's example 2. Notice, if you're stuck in the homework for time, of course you'd be better off if you did every question right all the way through so they worked out. But if you're worried about time, you could stop there and set up and just set them up. All right. Now, it's impossible for you to check your answers in the book because the book will go through and solve each of the problems. So you need to keep that in mind. If you're stopping there because you're worried about finishing your homework, you should be checking with the neighbor and see if you're getting the same equations as a neighbor. Example 3. Percents in liquids. Miss Hillary makes a 5% acid solution with 15% acid solution to make a 9.5% acid solution. Notice they're not even, so it's not a 50-50 mix. She wants to have 4 liters. How much of each liquid does she need? Well, again, let's set up this table. What do we have? how much of each liquid. We need the weak solution and the strong solution. So what do we have in our table? We've got weak solution, strong solution, and total. Again, well, we have the amount, right? How much of each liquid. This is all we want to find. We want to find how much of the weak liquid, what amount, and how much of the strong. I'll call that S for strong, even though my S's look a lot like 5s. That'll be okay. And we need to have 4 liters in total, right? So there's an equation. I can see that one already. And then we have talking about the percent. This weak solution is 5% acid. So this is percent acid. Excuse me. Well, 5% of this is acid, then 5%, notice that I wrote it as a decimal, and 15% of the strong one has to add up to a 9.5% solution. So 9.5% of what? Of the total, right? So I got to multiply by the total amount of solution I want, and that gives me an answer of, let me see if I can find it here, jam that into a calculator, I get 0.38, and there's my 2 equations. My first one, W plus S equals 4, and 0.05 W plus 0.15 S equals 0.38. And again, there's my 2 equations. That one looks like it needs to go through spring training. I could use either elimination or substitutions from this. And again, I'm going to stop there. My full solution's right here. I'll let you have a quick look at it. No need to copy it down. You can look at it on the Facebook group or print them off from the Facebook group. What did I do? I used elimination. I multiplied the first one by -5, multiplied the second one by 100 so that I'd get 5s in front of the W's, and then it works out pretty nicely after that. Okay, you see I substituted back there, even though I never said that I substituted back. Example 4, finally. Ferd invested some of his money. Oh, this is a money question. Nice. In a bond account and a mutual fund earning 8% interest. Overall, he earned $255 interest. Help him out by finding how much he invested in each account. So how much he invested in each account, that's what we want to find. So we've got the bond and the mutual fund and total. And again, this is starting to feel similar as the last 3, but each situation is a little bit different. The amount that he put in the bond fund, we'll let that be B. The amount in the mutual fund is M, and that's what we want to find. In total, he invested $6,000. Here, the second line isn't the percent acid or the value of the peas and carrots or anything. This is the percent interest, right? And on the bond, he got 3% interest. Mutual fund, he got 8% interest and made $255 in total. Notice that's already the total interest, so I didn't need to multiply that. If that was given as a percent, I would have had to multiply that. And notice, once I've organized this all into my table, this would be kind of like our A and B steps from our earlier setup, or it's also the G and the R all together, right? The given and the required all written into this handy dandy table. And then from here, I can write my 2 equations and 2 unknowns. And they kind of feel all the same, don't they? I hope so. Lots of different types of questions, and hopefully you'll also have lots of time to practice them. And that's why I'm kind of rushing through and not showing you all the steps so you get a chance to practice. So this first equation is from the amount that Ferd invested, and the second equation is for the percent interest. And then I'm going to go dot, 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 stop there, not finish it, excuse me. And the actual answer is right there with all the all the dirty details, all the nitty-gritty right there. It looks like $1,500 was in mutual funds and $4,500 in bonds. And you're welcome to go through and try these, but the big goal for today is to get to this point where we've got two equations and two unknowns. Okay, that's it. The supervising teacher will have a whole bunch of homework for you, so get to it. Good luck.